Hello, this is Mr. Stansbury. I'm going to take you through the notes on discrete probability distributions. At the end of this, you should be able to say, I can construct a probability table, graph a distribution, find the mode, and find the median from a probability distribution. Okay, so first thing, what is a probability distribution? A probability distribution describes the probability that a random variable will take a particular value. Okay, the probability that the variable x takes the value, like lowercase x, is signified by writing p, probability that x equals x here. Okay, which I know right now does not make gobs of sense, but we are going to get there. This here, I'm going to suggest that you probably don't write all this stuff down because it's probably, this is really for the people that really like the formulas and where things come from. But if x is a random variable with possible values x1, x2, x3, all the way to xn, so these are all the possible outcomes. So like, you know, picture like a six-sided die. That would be 1, 2, 3, 4, 5, and 6. And corresponding probabilities, probability of the first, second, third, all the way up to p of n, which all of these, if it was a six-sided die, would be 1 out of 6, 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 1 out of 6. Such that p of x, the probability of x, so like say the probability of rolling a 1 is going to be 1 out of 6. Okay? And then that's going to equal p sub I, where I equals 1. Okay, so the probability of all of these things added up together are always going to have to equal 1 is the idea. Okay, so the first one, I, is 1 all the way up to n. So, sorry, then what this means here is that every probability has to be between 0 and 1. And that means 0% to 100%. Okay? This here means if you add up all the probabilities, probability of getting a 1, a 2, a 3, 4, 5, 6, all those are going to add up to 1. And then the probability of 1 all the way up to the probability of n describes the probability distribution of x, which we're going to talk about here a little bit more here in a few minutes. Okay. For example, suppose that x is the number of heads is up when 2 coins are tossed. The possible values for x are 0, 1, and 2, right? Because you can get 0 heads up, you can get 1 head, or you can get 2 heads with corresponding probabilities. 1/4, 1/2, 1/4, because probability of getting no heads, that means you get both tails. That's 1 out of 4. The reason why the second one is 1/2, because you could get either heads tails or tails heads. That's 2 of the 4 possibilities, so that's why that's 2 over 4 reduces to 1/2. And then the probability of getting both heads, it's only 1 out of 4 ways to do that. Okay, so we see that each probability is between 0 and 1, and the probabilities add up to 1 because 1/4 plus 1/2 plus 1/4 equals, if you add those all together, is going to equal 1. Okay, that's kind of the idea there. We're going to keep exploring this a little bit further here. Uniform discrete random variable. So the key word in here is being the uniform piece here, where all the positive values, possible values, x, x1, x2, x3, all the way up to xn, all have the same probability, 1 over n, of occurring. That's uniform because they all have the same probability. Okay, so an example, rolling an 8-sided die, and the result is x. All the possible values are 1, 2, 3, 4, 5, 6, 7, and 8, and each value has a probability 1 out of 8 chance of occurring. Okay. Now with that, the mode is the most frequently occurring value, the data value x sub I, whose probability p sub I is the highest. So it's basically, just think of the mode, it's the most frequently occurring value. Okay, and then these xi and pi's will make more sense as we dig a little deeper into this here. And then the median is the middle value, when the cumulative sum of all of the probabilities, P1 plus P2 plus all the way up to P, and they're just calling this one J here, reaches 0.5. Okay, which is, excuse me, half. All right, oops, Let's see. So let's do this. Let's take a quick peek at an example here, and that will help us out. But before we do that, let's take a quick little comedy break. Okay. Example 2, a record store recently had a sale on some hot new releases. 7% of the people that came in purchased all 4 of these hot releases. 16% purchased 3 of them, 21% purchased 2 of them, 24% purchased 1, and 32% purchased none of those, of course, at their loss. Let X be the number of albums sold to a randomly selected customer. State all the possible values of X. Okay, so basically, it's how many albums could these people have bought if you were to walk into the store. So, oops, let's see, X could equal 1. Oh, sorry, actually 0, right? 0, 1, 2, 3, or 4 could be all of the possible outcomes, right? Part B, construct a probability table for X. Okay, so here's what you want to have: 0, 1, 2, 3, or 4. That's our X here. And then the probability of that happening. So probability of people purchasing none, that was 32%. So we call it 0.32. 1 was 24%, 0.24, right? And probabilities we always want to have as like a fraction or a decimal. We don't want to leave them as percents. It's pretty much, yeah, always fractions or decimals. Okay, 2 was 21%. 3 was 16%. And 4 was 7%, 0.07, okay? Graph the probability distribution. Okay, so so all we're going to do is just simply graph these here. So 0 was 32%, so there's 0.3, so 0.32. Let's call that right about up here somewhere. So we're going to graph that. We make ourselves a nice little bar chart here. And then 1 was at 24, so we'll call 24 about right here. Right, and we're just making our bar chart. And then, let's see, 2 was at 21, so just a little bit lower than that. 3 is at 16. So that's up about here-ish. And again, as long as you're right in the right neighborhood, we'll be good. And then 4 was 0.7. So then that's what our chart would look something like. Okay? Okay, and then find the mode and the median of X. Okay, so remember the mode is the one that happens most often, which is going to be this one right here. So the mode is going to be 0. Okay, and then what we want to do now is find the median. So to find the median, what you want to do is you want to start adding these together until you get to at least 0.5, which is 50%. So if we take 0.32, that's not enough to hit the mode. So then we add the next one, which is 0.24, which actually gives us 0.56. So that means this second one here. So our median is going to end up in this in the group that purchases just one record. Okay, and again the mode here is 0 because that's got the highest bar on the bar chart there. Okay, or the highest probability. Okay, so that's how you find mode and median. Again, for median, I know that's a little confusing. You just start from the beginning and just add up until you get to at least 0.5, and whichever one the last one is that you had added, that's going to be the median. So let's say if these were both a little bit lower and that only got us up to 0.48 or something like that, and then we added the 2 and that got us to 0.59, then the median would be in the 2, would be 2 right there. Okay? Okay. One last thing to take a look at here is probability mass function. Gives you probabilities for discrete random variables, also called a frequency function. And what we mean by that is this. Example 3, show that p of x equals x minus 2 squared over 15 and x equals 1, 2, 3, 4, and 5. Show that that's a valid probability mass function. Okay? So basically, in order for it to be a valid probability mass function, that means that all the probabilities here, all probabilities have to add up to 1, excuse me. All probabilities add up to 1. Okay, so then all we'd want to do is just plug each of those in, get our numbers, add them all up, and make sure that it equals 1, right? So if we plug in 1 minus 2 squared over 15, that's negative 1 squared. That's going to give us 1 over 15, right? So this is 1. 2, we're going to get 2 minus 2 squared over 15, and that's going to give us 0 out of 15. Okay, third one is 3 minus 2 squared over 15. 3 minus 2 is 1. 1 squared is still 1 out of 15. Plug in 4 there, and we get 4. Oops. Let's make this a little nicer, a little cleaner. 4 minus 2 squared over 15. 4 minus 2 is 2. 2 squared is 4 out of 15. And then for number 5, we would do 5 minus 2 squared over 15. 5 minus 2 is 3. 3 squared is 9/15. So if we add these, well, first thing we actually got to check is make sure that all these probabilities are between and including 0 to 1. Okay, so the only one that could be a problem here is this 0 out of 16. It's equal to 0, that's okay. As long as it's not less than 0, then we're okay. It can't be less than 0 or more than 1. Okay, so if we add all these up, so we've got 1/15 plus 0/15. Oops, I shouldn't be putting commas. I should be putting plus signs. Addition. 0 over 15 plus 1 over 15 plus 4 over 15 plus 9 over 15. All the denominators are 15, so that makes it easy. And 9 plus 4 plus 1 gives us 15 over 15, which equals 1. So we have shown that it's a valid probability mass function. Okay, so this one works because all these probabilities should add up to 1. If they don't, then that means that there's either we had some kind of math error, or not all the different possible outcomes are included in our x's here. Okay? Okay, that's all we have for discrete probability distributions. If you have any further questions, please feel free to ask. Thanks.